Hey, it's Mr. Stoletano, and this video is going to be on ionic compounds. So first of all, let's refresh on what compounds are again. So compounds are made from more than one type of atom, which is chemically bound, right? So they can't be separated except for by chemical means. So you can't break those bonds unless you do a chemical reaction. So those two different types of atoms are chemically bound. And the properties of the compound are usually very different from the elements that make it up, which we'll look at in a minute. And each element is represented by a 1 or 2 letter chemical symbol, which is used to write the chemical formulas of compounds, and the elements are always present in the same ratio in a certain compound. So let's look at, for example, the element sodium, which we looked at in class. The element sodium looks like this. It's a metal, and it cuts like butter. The nonmetal chlorine is a gas. So the nonmetal chlorine is a gas, and when you combine them, you combine sodium and chlorine to make sodium chloride, it's very different. This is sodium chloride, which is just table salt right down the bottom. So again, the point is that the properties of the compound are very different from the properties of the individual elements. Also, salt, NaCl, is always in that ratio of 1 sodium for every 1 chlorine. So that's what makes that a compound. Okay, so what makes something an ionic compound then? So ionic compounds, which NaCl is actually an example, must be made of a metal and a nonmetal. That's the requirement. You must have both a metal and a nonmetal. So if we look over here, here's our metal, sodium, and we combine that with our nonmetal chlorine, and we have the ionic compound sodium chloride. This is also true for magnesium fluoride, which is magnesium, a metal, and fluorine, a nonmetal. So again, you must have a metal and a nonmetal to make an ionic compound. So what makes them come together in the first place? Well, there's this rule that's going to be really important called the octet rule. And what happens with the octet rule is atoms can become very stable by having 8 electrons in their outer shell, or 2 electrons in the case of the smallest atoms, like hydrogen and helium, right? So we also call this noble gas configuration. And so what we mean is that the happiest elements have 8 electrons in their outer shell. They're also considered kind of the coolest of the elements, like neon, and everybody wants to be just like them. So here's neon. Neons get 8E in the outer shell. It's very happy. And so all the other elements want to be just like that. They're going to try to do all they can to be like the noble gases. So which group of periodic table follows the octet rule again? Well, the noble gases do, right? The noble gases fill that outer shell. And they're called the noble gases because they don't react with the commoners, so the rest of the periodic table. They're kind of above the rest of the periodic table. They're not very reactive at all. So they're very stable because of that, because they have that filled outer shell, and so they're happy. And yeah, again, so they're happy with their outer shell. And they don't need anybody else, so they kind of exist by themselves as what's called a monoatomic. So it's just you just see helium as He. It doesn't have to be combined with anything else. It doesn't have to react with anything else. So what happens for the chemical reaction for sodium and chlorine? Well, in the case of that, just like in the case with any ionic bond, the metal loses its electron and it gives it away to the nonmetal. So if we actually look at sodium before it gives away this electron that's coming over, it has 1 valence electron, right? It's in that first column. And so when it gives away that 1 valence electron, it's left with a full outer shell, which is exactly what it wants to do. It wants to have a full outer shell. And chlorine, before it accepts that electron, has 7 valence electrons if you were to count these on the outside. Once it accepts that electron from sodium, it also becomes happy. So this is like a mutual agreement. They're both like, yes, I got exactly what I wanted, thank you. And so they both become happy that way, and that's why this bond happens in the first place. And again, it's because all the elements want to have a full outer shell, the octet rule. So again, sodium gives up its 1 valence, and it gives it to chlorine to give chlorine 8 in the outer shell, and sodium 8 in that next shell, just below it. It still counts as a full shell. It's just the shell below it. And so essentially this is what we're going to see, is that elements will either gain or lose electrons to try to be like the noble gases, or they're going to share them. Right now we're going to focus on gaining and losing. And here's just our noble gases. Again, they have either 2 or 8 valence electrons in their outer shell, which makes them stable. So like we said, sodium loses 1 electron, and it now essentially what happens is that once sodium loses that electron, it still has the same number of protons, which make it sodium. So once it loses that electron, it actually becomes positively charged because now it has 1 more proton than it does electrons, because it used to be even, right? Now chlorine used to have an even number of protons and electrons, but now it picked up that electron. So chlorine becomes negative. So here's what we see over here. Sodium becomes positive, and chlorine becomes negative. Now this is what another way to see that. Again, originally sodium has 11 protons and 11 electrons. It loses that 1 electron, so now it has 11 protons and 10 electrons. Sodium has become positively charged. It's called an ion, a charged particle. Same thing over here with chlorine. Chlorine had 17 and 17. It was even, no charge. And then it picked up that extra electron, and now it has 18 electrons and 17 protons, so chlorine became negative. Nothing happened to the nucleus. We're just talking about electrons here. Electrons are important for chemical reactions. And the other important thing is that even though there's a positive and a negative charge involved here, the charges cancel out. So the 1 plus from the sodium cancels out the 1 minus from the chlorine, and the compound itself is neutral. So it's metal and non-metal together, and it's a neutral compound. That's very important. Okay, so the name for a positive ion is called a cation. And the way you can remember that is that cations are positive. So cations are positive. Boing. So then, which is the cation for NaCl? Well, the cation for NaCl was that positively charged Na+, essentially. That sodium ion. So sodium is the cation in this case because it's positive. Now the way to remember an anion, which is a negative ion, is anion is like an acronym for a negative ion. So which is the anion in sodium chloride? Well, the anion is the chlorine, right? Because the chlorine became negative. So the positively charged guy will be the cation, the negatively charged guy will be the anion. Okay, so let's rehash what we just talked about. Metals. In an ionic compound, you have to have a metal and a non-metal, right? So the metals, where they gain or lose their electrons. Well, the metals are going to lose their electrons. And remember, we said those electrons are loosely bound anyway. These guys in this column want so bad to dump off their electrons so they can be just like the noble gases. What about the nonmetals over here? What are they going to do? Gain or lose electrons? They're going to gain them because they are so close to being like the noble gases that they could just pick up a couple. The metals, when they lose those electrons, are they going to form a positive ion or a negative ion? They're going to form a positive ion because you got rid of a negative. It's a weird concept, but if you get rid of a negative, you become positive. And then the nonmetals, when they gain those electrons, are they going to become positive or negative? Well, they're going to become negative. Okay, lastly, when the metals lose those electrons, what is the name of that ion called that it becomes? A positive cation. And then when the nonmetals gain the electrons, what is the name of that they become? An anion. And the most important thing that happens with that is that once the cation gets rid of that electron and the anion picks up that electron, it gives them a charge which makes them a cation and anion. So first they're just regular atoms. But once that happens, the positively charged cation becomes attracted to the negatively charged anion. And so that forms the bond. An ionic bond is an attraction between a positively charged cation and a negatively charged anion. And in order for a bond to be ionic, for a compound to be ionic, it has to be metal and a non-metal. That's it for ionic compounds. Thank you for watching. Remember, chemistry is everywhere.